Okay, so welcome to lecture number 20, and today we will study about signal flow graph. So in the last lecture, we studied how to find out the transfer function by using block diagram reduction technique. In that, we have seen simple systems as well as multi-input, multi-output system. Now, this block diagram reduction technique is somewhat tedious, okay, and it is time-consuming. So, question is that is there any alternative method by which we can basically find the transfer function of any complicated system very quickly? So, answer of that question is yes, and the method is by using signal flow graph. So, SFG. So, what is signal flow graph? Who has developed that signal flow graph? And then how to find out the transfer function by using signal flow graph? What is that Mason's gain formula? So that we are going to study in this lecture. So particularly in this lecture, we'll see the fundamentals of signal flow graph, terminologies, and Mason's gain formula. And maybe in next two lecture, we'll take some problems also remaining part of this one. In signal flow graph, first we'll see the definitions, what are the different definitions, the terminologies and example, and then after that we'll be studying the Mason's gain formula with example, and then finally how to obtain the signal flow graph from the block diagram. So that we will study in this lecture, right? So as I said that this one, block diagram reduction technique was basically a time-consuming and tedious technique. You have to apply several rules. There were near about 12 different rules are there, and then it was time-consuming. So to overcome that limitation, this S.J. Mason, Samuel Jefferson Mason, okay, he developed a signal flow graph method, and this method to find out the transfer function by using this method, he has proposed a Mason's gain formula, which is he has proposed a formula which is known as a Mason's gain formula. By using that Mason's gain formula, you can find out the overall transfer function of any complicated system. So advantage is that availability of signal flow graph gain formula is also called as the Mason's gain formula. By using this Mason's gain formula, you can directly calculate the transfer function of any complicated system, and it is less time consuming and so on. So a signal flow graph consists of a network. Now when you are saying that it is a graph, so what graph consists of? Graph consists of nodes and edges. So in the graph, there are edges as well as there are nodes. So by using edges and nodes, we can basically find, or we can develop the graph, and this graph, by using this graph, we can find out the overall transfer function and so on. So a signal flow graph consists of a network in which nodes are connected by a directed branch, or this is also called edges or branch and so on. So it will detect the flow of signal from input to output. So in which direction that signal is flowing, where it is adding, where it is terminating, where takeoff point is there, and so on. So like that way. So it depicts the flow of signal flow from one point of the system to the another, and it gives the relationship between all the nodes and edges and so on, right? Now, see the fundamental of signal flow graph. For example, we have been given the mathematical equation like this: y is equal to ax. So, what will be the signal flow graph of this mathematical equation? So you know that this is a variable y and x are the different variables. So y is the output variable, x is the input variable, and this x signal will be get multiplied with the a gain. So this can be represented by a signal flow graph in the simple way like this: y is equal to x into a. So this is the gain of that branch or path which will be multiplied by, okay, which will get multiplied with the signal x. So x into a is equal to y. So this simple mathematical equation, this can be represented by using a signal flow graph as a simple y is equal to y. This is the output. Y is equal to x multiplied by a. So a is the gain of that path. So the signal flow graph of the above equation is given by this one. I hope that you have understood how to represent that simple mathematical equation by using signal flow graph. Now see that here, this is one node, this is another node, and this is the branch. Okay, so branch is having a gain equal to a. Now this relation between this node and this node is equal to, this signal will be equal to what? This signal multiplied by this branch gain. So y is equal to x into a. So this signal flow graph gives the relation between y node and x node. Y is equal to x into a. So every variable in a signal flow graph is designated by a node. Now here, which are the variables? Y is one variable whose value changes, x is another variable whose value changes, and a is constant. Okay, so the variables, okay, when you are representing this mathematical equation, variables in that equation will be representing nodes. So x is a variable which is represented as one node, y is another variable which is also represented as a node, and the constants will be represented by a path. Okay, so this a is a constant which is represented by the path or age. So y is equal to x into a. So every variable in the signal flow graph is designated by a node, and every transmission function in a signal flow graph is designated by a branch. So this is the transmission function. And you know that these branches are always unidirectional. Unidirectional means signal will flow from one end to another end. It's not a bidirectional. So it's not like that signal is, now here signal is flowing from x to y. At the same time, it will not flow from y to x and x to y. So it will be x to y here. So branches are always, in signal flow graph, branches are always unidirectional, means signal will always flow either from left to right or right to left, not at the same time left to right and right to left. And the arrow here represent the signal direction. See that this arrow is representing that signal is flowing from x to a, and while flowing, this is getting multiplied with the function gain function a. So the arrow in the branch denotes the direction of the signal flow. Okay, I hope that now this is very clear that this mathematical equation can be represented by a signal flow graph like this way, where these variables will be represented as a node and the constants will be represented as the branch, and then that this signal flow graph gives the relation between input node and output node and so on. So here y is the output node which is represented here, x is the input node which is represented here, and you know that y is equal to x multiplied by a. So here this x signal get multiplied with the gain function a, and that is equal to y, right? And this x and y are the node, and this a is nothing but the branch, and the signal flow will be always in unidirection and so on, right? And the arrow of that signal gives the direction of that signal. Now, see that another example here I have shown one equation, mathematical equation is y1 of s is equal to z11 of s into r1 of s, means see that y1, r1 and r2, these are the variables, whereas z11 is the constant, z12 is constant which we call as a gain. Now this can be represented as a signal flow graph. Now see that here how many, there are two equations, so there will be two outputs. So y1 is one output and y2 is another output. So this y1 and y2, these are the two output, and r1, basically see that r1 and r2, these are the two inputs. So r1 is one input and r2 is another input. So generally input terminals are taken on the left side and output terminals are taken on the right side. So input node is on the left side and output node is on the right side. Now see that this output node is related with which input node? R1 and R2. So R1 as well as R2. So how it is related with R1? R1, it is related with a multiplying gain factor G11. So this R1, this signal will be get multiplied with G11. So this one, and that will be given as one of the input to y1. So r1 into z11, this signal, plus, see that this is the plus, another signal is coming from r2. So r2 multiplied by g12, so that is nothing but overall y1, right? So this is the signal direction from r1 to y1. So this is from r1 to y1, and r2 to y2 is multiplied with z12. Similarly, for y2, okay, there are two signals. One is coming from r1, so this is coming from r1, and another is coming directly from r2, right? So r1 signal is getting multiplied with the gain g21, so this is the g21 gain, and plus this is another signal which is coming from r2. This is multiplied with the gain function g22, so this is g22. So for these two mathematical equation, signal flow graph will be like this. So in this way, we can construct the signal flow graph from the given mathematical equation or given mathematical model of physical systems, right? I hope that you have understood how to obtain the signal flow graph from the given mathematical equations, right? Now, can you do this one? So here, like for example, you have this equation. So R1 and R2 are basically inputs, and X1 and X2 are the outputs. So this X1 and X2 is the output, and you have been given the equation for X1, A11 X1 plus A12 X2 plus R1. So what you have to write, basically you have to draw the signal flow graph, and for this equation as well as this equation. So this is the entire, these are the two entire equations of given system. So can you draw this signal flow graph? Okay, just quickly, can you draw somebody and show me the output? What will happen basically here? You have to take X1 as the output node, X2 as another node, R1 as one input node, and R2 as another input node. And just you have to connect this X1 with one signal is coming from R1, another signal is coming from X2, third signal is coming from X1. So there will be a self signal here, right? Similarly, for X2 also, one signal is coming directly from R2, and another signal is coming from X2 with a gain of A22, and third signal is coming from X1 with a gain of A21. Now see that here, if you draw the signal flow graph, it will be like this. So X1 is one output node, R1 is input node, X2 is second output node, R2 is second input node. Now see that X1, what is the gain of this multiplying gain for R1? It is, if it is not there, it will be 1. So X1 is equal to R1 into 1. So that is directly there. And you know that one more signal is coming from X1 itself, and then so that's why there is a self loop which is having gain equal to A11. So this is A11, right? And another signal is coming from X2. So this is X2 node, and what is the gain of that one? That is equal to A12. So that's why this side signal direction is like this. So X1 is equal to R1 plus X1 into A11 plus X2 into A12. So this is the equation, mathematical equation, which we have represented that one in a signal flow graph, right? Similarly, for X2, how many inputs are there? Or how many there are inputs? R2 is one input, X2 is second input, and X1 is third input. So for X2, there are three signals coming. One is directly coming from R2 having gain equal to 1. So for X2, one is coming directly from R2 having gain equal to 1. So signal direction is like this from R2 to X2. Another is coming from X2. So X2, there is a self loop. So A22, it is originating from X2 and terminating at X2. So that's why it is called as the self loop, right? Then third one is coming from AX1, and what is the gain of that one? A21. So this third signal is coming from this one X1, and whose gain is A21. So in that way, we can develop the signal flow graph model for a given mathematical equation. I hope that now this is very clear to you how to draw the signal flow graph from the given mathematical equation, right? Now, see that another example. here. Like here you have four equations. So x0 is your input and x4 is output. And in between there are other variables, like the x0 is input variable and x4 is output variable. But between x0 and x1 there is x1, x2 and x3, right? So equations for x1 are given, equation for x2 terminals are given, equation for x3 is given, and equation for x4 is also given. So since how many variables are there? There are x0, x1, x2, x3, and x4. So there are 5 variables. Means how many nodes will be there? There will be 5 nodes. Now out of that, x0 is input node and x4 is output node. So what we have done, we have plotted basically, or we have drawn x0 at the left side and x4, since x0 is input and x4 is output, so x4 we have drawn at the output side, right? And between x0 and x1 there are 3 nodes. One is x1, another one is x2 and x3. So x1, x2 and x3, these are the 3 nodes. Now for every node there must be some signals coming. So what are the, okay, for x1, see that which are the signals coming from. For x1, one is coming from x0, another one is coming from x1, and third one is coming from x2. So what is x0? For x1, which signal is coming from x0? So this x0 signal is getting multiplied with a. So this x0 is multiplied with a. So this part is drawn here. Now for x1 here node, this self loop is there and having a gain equal to b. So this self loop is there having a gain equal to b. So this part is over. Now there is one more signal which is coming from x2, that is okay having gain equal to c. So x2 is having gain equal to c. So at terminal x1 there are 3 signals. One is coming from x0, another is coming from x1 itself, and third one is coming from x2. Okay, so this mathematical equation is okay. With the for this mathematical equation we have drawn this signal flow graph. So for x2 node, how many inputs are there? There are 2 inputs. One is from x1 and another one is from x3. So from x1 gain is d. So see that x1 signal multiplied with d, and this is terminating at x2. Okay, one more is coming from x3 and whose gain is e. See that, that's why signal direction is from x3 to x2 whose gain is e, right? So this is for x2. What about x3 node? For x3 node there are basically 2 signals. One is coming from x0, okay, and another is coming from x2. Okay, so x0 for x3 directly x0 is coming and having a gain equal to f, and for this one x3, one more signal is coming from this one x2 and having gain equal to z. So this is z, x2 multiplied by z, and this is x0 multiplied by f. So that is overall x3, right? For x4 there is only one signal coming from x3 with a gain h. So for x4 this signal is coming from x3 with a gain h. So like that way, even if you have been given any kind of complicated mathematical model, you can easily draw a signal flow graph from this mathematical model by just looking which are, okay, how many signals are input signals and which is terminating signal or output and so on. So just you have to know which are the variables, which are the gain factors. So variables will be represented with only nodes, gain factors will be represented with the path, and then how those nodes are, okay, which signals are coming to that node. So from that equation you will come to know, and then you can draw the signal flow graph. I hope that this is very clear to you people how to draw the this one. Now construct the signal flow graph for the following set of formula. Okay, simultaneous equation. Like for example, this is one equation, this is another equation, and this third equation. So definitely you have to know that how many variables are there. So see that x1 is one variable, x2 is another variable, x3 is third variable, and x4 is fourth variable. So in total there are basically 4 variables. So we have drawn 4 nodes, x1, x2, x3, and x4. And then from this equation okay, you can draw this one. From this mathematical equation, you can draw the signal flow graph. So for these three equations, signal flow graph is coming like this way. Another alternative method also you can draw. Okay, you can also draw in this way also. There, okay, other possibilities are there, but overall transfer function will remain same. So there are four variables in the equation. These three equations, x1, x2, and x3 and x4. Therefore, four nodes are required to construct the signal flow graph. So x1, x2, x3, and x4. Arrange these four nodes from the left to right and connect them with the associated branches. So we have done that one in this way. Or another way to arrange this graph as shown in this figure. So another way also you can do it. So I hope that you have understood this example also, how to construct the signal flow graph from the given mathematical equation. Now the terminologies which are used for signal flow graph, we will study those terminologies. Like for example, what is by input node, what is by source node, what is by output node, what is by sync node, what is by path, what is by forward path, feedback path, loop, and so on. So, okay, unless and until, or two non-touching loop, three non-touching loops, unless and until you know all those terminologies, you'll not be able to understand this Mass-Sixgen formula. So first we'll study all those terminologies, and then we'll study the Mass-Sixgen formula. Now, see that here, x1, x2, x3, x4, these are basically variables, right? Out of that, x1 is your input node and x4 is output node. So input node, where see that if you look at the input node, always from input node, signal will be originating from the input node. Okay, there will not be any signal which will be terminating at the input node, right? So input node, or this is also called the source node, only outgoing branches are there. So here only outgoing branch. There is no incoming branch for this node. So that node is considered as the input node, right? So here, where only outgoing branches are there, that node is considered as an input node. So now here, x1 is the node where only this branch is, outgoing branch is there. Okay, so this node is called as the input node, or also it is called as the source node. Whereas in the case of output node or sync node, okay, it contains only incoming branches. There is no outgoing branch, right? If there is any outgoing branch, then you have to add one more node, and okay, make sure that it will be having only one, or it will be having only incoming signals or incoming branches. Now x4, only incoming branches are there, or incoming signals are there, which is coming from x3 to x4 and then x2 to x4, right? So output node or a sync node contains only branches coming. Okay, so this output is this node is considered as an output node where only incoming branches are there, or this is also called as the sync node, and this x1 is the input node, or also called as the source node where only outgoing branches are there. I hope that you have understood what is by incoming, okay, input node and what is by output node. So here x1 is input node and x4 is output node, right? Now, the third terminology which is generally used in a signal flow graph is path. So in which path the signal flows? So there may be multiple paths. Like for example, signal is traveling from x1 to x2, x2 to x3 with this path, x3 to x4. Another path is there, so which is okay, traveling signal is traveling from x1 to x2 and then x2 to directly x4. So this is one path, this is another path, and so on, right? So path is a continuous unidirectional succession of the branch along which no node is passed more than once. See that, for example, can I consider this as a path, x1 to x2, x2 to x3, and x3 to x2? What happens basically, this signal is terminating here, okay, again traversing this x2 node twice. And what is our path definition? That signal should not traverse that node, okay, more than once. So this cannot be considered as a path. Basically it will be considered as a loop, because signal is starting from the node and terminating at the node. So this is considered as a loop, not as a path. So in the path, basically signal should traverse only once, okay, or a path is a continuous unidirectional succession of the branches along which no node is passed more than once. So here there are two forward paths. One is x1 to x2, x2 to x3, x3 to x4, right? So this is one path. You cannot consider this one also. This is a loop basically, because signal is starting from the point and terminating at the same point, right? Another path. Can you consider this x1 to x2 and x2 to x3? No, because this x1 to x2 signal is from left to right, whereas x2 to x3 it is from right to left. So it is not in a direction. Okay, so it's not in same direction. So this is not a path for this one. So it will be x1 to x2, x2 to x3, x3 to x4, or see that x1 to x2, x2 to directly x4. So a path is a continuous unidirectional succession of the branches along which no node is passed more than once, right? Now, forward path means signal is traveling from input to output, right? So a forward path is a path from which input node to output node signal will be traveling from input node to output node. So see that is x1 to x2, x1 to x4. Which path is there? Signal is traveling from x1 to x2, x2 to x3, x3 to x4. So this is one forward path. Another forward path is that signal is coming from x1 to x2 and then directly x4. So this path and this path is these two paths are called as the forward path. Okay. Whereas feedback path means, or it is also called as the loop, means it will start from the same node and terminate at the same node. So a feedback path or a feedback loop is a path which originates and terminates on the same node. Like for example, here this signal is starting from x2, going to x3, again coming back and terminating at x2. So this is one feedback loop or feedback path, or this is also feedback path, no? So because it is starting from x3 and terminating at x3. So when it is starting from same terminal and it is not traversing any other, so this is called as the self loop. Okay, this is called as the self loop, whereas this is called as the feedback loop, right? A feedback path or feedback loop is a path which originates and terminates on the same node, that is x2 to x3 and x3 to x2. So this is called as the feedback loop, whereas this is called as the self loop, right? I hope that now it is understood to you people. These terminologies means what is by input node or source node. So input node or source node has only outgoing branches, okay, and output node or sink node where you have only incoming branches, and a path is nothing but a continuous unidirectional succession of the branches along which no node is passed more than once. Okay, forward path means a signal where input will travel from our signal will travel from input to output, and then feedback means basically signal will start from the same node and terminate at the same node by traversing other terminals or nodes and so on. And self loop means basically it will start from that node and it will terminate at the same node, but without touching to any other node, right? So this is called as the self loop. Now see that so basically see that here one path is forward path is this one, x1 to x2 x4. Another forward path is what this one, x1 to x2 x2 to x3 x2 to x4, and then so this is entire forward path, and then this is one more forward path, and then this is the loop, okay, and then so entirely. Now what is by self loop? Self loop is nothing but the feedback loop consists of a single branch, that is A33 here. It is starting from this x3 and terminating at this x3 without touching to any other node. So this is called as the self loop. Okay. Now the gain of the branch is the transmission function of that branch. So what is the gain of this branch? Signal. This is one branch. So what is the gain of this one? A21. What is the gain of this branch? This A32, because it is starting A32. See that it has been given where it is going to 2, from where it is coming 1. So it is A21. Okay, here also it is going to 3, coming from 2. So this is A32. What about this one? It is going to 2, coming from 3. So this is A23. What about this one? It is starting from 3 and terminating, okay, starting from 3 and terminating at 3. What about this one? It is starting from 2 and terminating at 4. So starting from 2 and terminating at 4. What about this one? Starting at 3 and terminating at 4. So this the gain of this one is A43, right? So the gain of the branch is a transmission function of that branch, or also it is called as the simple gain. And then path gain. So entire path gain, like for example, we have two forward paths are there. One is x1, x2, x3, and x4. So this path gain will be just multiplication of, okay, the gain of individual path. So here x1 to x2, what is this one? A21, then A32, and then A43. So this total path gain will be equal to A21 multiplied by A31, A32 multiplied by A43, right? A43. What about this another path gain? So that will be equal to A21 multiplied by A42. So this is second path gain. What about loop gain? Loop gain will be basically the gain product of these branches. So A32 multiplied by A32. See that path gain is the product of branch gains encountered in traveling a path. That is the gain for gain of forward paths from x1 to x2, x3 to x4 is basically A21, A3, 2, and A4, 3. So this is the one forward path. What about the loop gain? The loop gain is the product of branch gains of the loop. That is loop gain of the feedback loop from x2 to x3. So this is A32, and from x3 to x2 it is A23. So A23. So this is the total loop gain, A32. Now, when we can say that the two loops or path, they are not touching to each other if they does not have any common node, right? Then those two paths or those two loops are said to be non-touching loops, right? So the two loops or path or loops and paths are said to be non-touching if they have no common node. Now, how many loops are there in this? There are two loops. One is this one, A32 multiplied by A23. So this is one loop, and another one is this self loop A33. So in the given diagram, there are only two loops, but these two loops are touching to each other because this x3 is the node which is common for this A33 as well as for A32 and A23. So this is touching here. If it would have been like, for example, if this loop would have been here only, and then one loop is here, then this loop and this loop would have not been touching to each other. Then we would have said that these two loops are not touching. Means loops are said to be, two loops are said to be non-touching if they don't have any common node, right? Then and then it will be said as a non-touching loops. Okay. Now, so this is basically a self loop, and then another, okay, this one forward path, so which is touching to that this one. Then this is a loop, one loop, and okay, which is also non-touching. Touching to that one. Now consider the signal flow graph and identify the following. So where is the input node from this one? Can somebody tell me which is the input node? Yes, please.
R of S.
R of S is input node. Very good. Because where only output is there, right? So where only outgoing branches are there. What about output node?
C of S.
C of S. Very good. Right. Then can you tell me, okay, which are the forward path? Forward path means signal will travel from input to output. So just multiply those. Okay. Which is the forward path? Can you tell me? Forward path gain?
G1 of S, G2 of S,
Right.
multiplied by G3 of S, multiplied by G4 of S, multiplied
Right.
by G5 of S, multiplied by
Then,
G7 of S.
yes, so this is one forward path. We can call that as a P1 path, which is P1 is equal to G1 of S multiplied by G2 of S multiplied by G3 of S multiplied by G4 of S, G5 of S, and G7 of S. Is there any other forward path? See that signal will travel from input to output with that path also. See that this signal will come to this one, so this will follow this path, or this can follow this path also, na? Right? So G1 of S multiplied by G2 of S multiplied by G3 of S multiplied by G4 of S, and then G6 of S multiplied by G7 of S. So this is another forward path P2, right? Is this right or wrong?
Yes, sir.
Okay. Okay, fine. So there are two forward paths. What about the individual loops? How many loops are there? Means signal will start from that node and terminate at the same node. So this is G2 of S multiplied by H1 of S. So this is one loop now, right? Can you tell me another loop? Loop gain, another loop gain. This is one loop gain, G2 of S multiplied by H1 of S. Quickly, we have 2-3 minutes time only.
G4 of S into H2 of S.
Right. Is there any third loop in this? Where signal will start and terminate at same node? G5 of S into G6 of S. No, see that there is G5 of S in G6 of S. This is not a loop, because signal is starting from this node and terminating here. Here also this is terminating. It is not revolving around. See, in this loop, it is starting from Z4, again it is coming and then terminating at Z4. But here, this is not loop, this is the two forward paths are there. So from this node, V2 node, one signal is going outside like this G6 path, another is going like this. So this is not a loop. Loop means basically it should have unidirection. Basically, see that this is like this way. Here, this is like going this way, this is also going like this way. So it is not terminating at the same node, starting, okay. These are two forward paths, but you know that we have one loop G2 of S and then H1 of S. So this will start and then terminate at the same node. And then here it is starting from, at node V2, but it is terminating at V1. See that this signal, when you are considering this one, so it is not terminating at V2 only. But in this case, see that signal is starting from G2 and then terminating at G2 only. So that's why it is called as the loop. This is not loop, right? Because it is originating from V2 and terminating at V1. So originating node and terminating node are different, whereas here originating node and terminating node are same. So that's why it is called as the loop. This is not a loop, right? Whereas second loop is this Z3, this signal G4 and H2, starting at V3 and terminating at V3 only, right? Similarly, Z4 multiplied by Z5, so this signal will go up to this one, and then again it will come back to this node V3. See that signal is starting from V3, having gain path equal to G4 and then Z5 and then again H3, so terminating at V3. So we have third loop Z4, Z5, H3, right? So there are in total two forward paths, three loops. Okay. Now out of these three loops, this one loop, this Z4 and H2 and this G4, G5 and H3, they are having common node like this one and this one is common node for both. So they are not, they are touching to each other. But see that this loop L1, if you consider G2 multiplied by H1 and G4 multiplied by this one, Z4 multiplied by H2. So these two loops are not touching to each other because they don't have the common node, right? So these two loops are considered as two non-touching loops. Z2 multiplied by H1 and G4 multiplied by H2, right? So these two loops are considered as a two non-touching loop, or even Z2 multiplied by H1 and G4, Z5 and H3. These, so this combination is also considered as two non-touching loops, right? So we have, I hope that you have understood the concept of non-touching loops, right? So today we'll stop here, and in our next lecture we'll study Mason's gun formula, and then after that problems on that one. So if you have any doubt, I'll be happy to answer your questions. Otherwise, we'll call a day. Yes, please. Okay, shall we call a day? Okay, fine.